Hello students, welcome to Narayan PU College online classes. So we have completed PU part of alcohol, phenols and ethers. So we have completed this chapter according to the NCERT textbook. So now we will go for competitive, and here we will give you some more information which we need for the competitive. So PU only we followed NCERT textbook, and now in this one we give some more information. Clear? And you see here we have already provided for you competitive books, that is you take the volume 5 and see the last chapter here, alcohol, phenol and ethers. So in this one, volume 1 and volume 2 and previous year's questions are there. So we will complete all these questions. If you want, you see the page number here 135. Page number here, volume 5, and page number starts here, page number 135, clear? So here alcohols, phenols and ethers. You see now exercise 11.1. So we will first discuss about 11.1. Clear? 11.1 contains here 45 questions, and 11.2 also having 45 questions, and the previous year questions are also there here, almost 16. So all we will complete in this class some questions, and the next coming class also we will go for competitive only. See the now first question. Carbolic acid is, the first one they have given here is carbolic acid. I already mentioned in the PU class only. And phenol is known as a carbolic acid. Phenol is known as a, what it is here, carbolic acid. Clear? And now second question. See the second question. Absolute alcohol. Your answer is, the first one is, first question option 1 is the correct one. Absolute alcohol, I already given in the means when we discussed about the ethanol, fermentation of ethanol, there I have already given. So what is that one is, the first one, rectified spirit, you already know that, rectified spirit, and what is the composition here, 95% of ethanol, C2H5, and some in books they have given 95.5% and 4.5% water. So it is also no problem, you can take and 5% of water. This we will call as a rectified spirit. And another one we have given absolute alcohol. Absolute alcohol means, you already know that, 100% ethanol. We will call as a absolute alcohols. Clear? And sometimes they will and here also some that we have not discussed in the PU part, power alcohol also there, and the alcohol which is used to produce the power. Clear? So what is that one here is rectified spirit plus petrol. And rectified spirit plus petrol. You know that rectified spirit means it is a alcohol, it is a polar, and petrol, you know, hydrocarbons, it is a non-polar. Both will not be mixed. To mix up this, we will use here benzene. Clear? So this is, and power alcohols also there, and methylated spirit also there. Methylated, you just note it down all. Methylated, you know, alcohol, or you can say spirit, methylated spirit. So in this one we have methanol plus pyridine, plus you will have rectified spirit. This is the combination. Rectified spirit. What is the methylated spirit here? Methylated spirit is a methanol, pyridine and rectified spirit. And you know another one is there here, raw alcohol. What it is here? Raw alcohol. You know 90% of ethanol we will call as a raw alcohol. Clear? And this is, you know, ethanol can also be called as grain alcohol. And you know, ethanol can also be known as grain alcohol. These all are important only. Grain alcohol. Clear? And you know, another one is there here, and rubbing alcohol. Rubbing alcohol. Clear? Rubbing alcohol. And this we will called as isopropyl alcohol. Isopropyl alcohol we will called as a rubbing alcohol. And you know that here 70% of methanol, CH3OH, this we will called as a methanol can be called as a wood spirit. So these are some important alcohols which are used in the, you know, competitive examination. Rectified spirit 95% ethanol, 5% water. Absolute 100%. Power alcohol means rectified spirit plus, you know, petrol, which is used to generate the power. And methylated spirit. Methylated spirit means methanol, pyridine and rectified spirit, and raw naphtha also they used here. This is not that much important, naphtha. Clear? Raw alcohol, 90% alcohol we will call as raw alcohol. Ethanol can also be known as a grain alcohol. Rubbing alcohol means isopropyl alcohol, and 70% methanol we will consider it as a wood spirit. Clear? So what is your answer now here? They are asking absolute alcohol. Absolute alcohol means what is the option here? 100% pure ethanol. That is option 2 is the, option 1 is the correct one. And next one. Go for the question number 3. So you note down all these are very important. Next one. Which of the following is dihydric alcohol? Dihydric alcohol they are asking. Dihydric alcohol. You know, we have already discussed the classification based upon number of OH groups present on the alcohol. And these alcohols are classified into mono, di, tri and polyhydroxy alcohol. Clear? So now dihydric alcohol means the alcohol should have 2 OH groups. See the first one they have given glycerol. They have given glycerol. Clear? You know what is the glycerol formula? We have already discussed. What is the glycerol formula? CH2OH, CHOH and CH2OH. How many OH groups are there? 3. This we will called as a trihydric alcohol. This we will call as a which one? Trihydric alcohol. But we need which one? Dihydric alcohol. Ethylene glycol. Glycol means, you know, I already mentioned here. 2 OH groups are there. Those compounds we will call as a glycols. Ethylene glycol. CH2CH2 ethylene glycol. CH2OH and CH2OH. This we will call as a dihydric alcohol. Third option what they have given? Catechol. Catechol means I already mentioned. What is the catechol? On the OH groups are present on adjacent side. That we will means ortho position. We will call it is a catechol. Have we discussed or not? We have discussed already catechol. It is a dihydric, but simple alcohol they are asking. It is aromatic alcohol. They should give here dihydric aliphatic alcohol actually. So it is also dihydric, but it is a aromatic. Clear? And next one is resorcinol. Resorcinol formula you already know. What is the resorcinol formula? And 2 OH groups are present at meta position, and here this we will called as a resorcinol. Clear? So this is what is our answer here? This is option second is the correct one. Next one is question number 4. You see, wood spirit is known as, just now only I have discussed here, methyl alcohol. 70% of methanol we will called as a wood spirit. So option 1 is the correct one. Fourth one is option 1. Clear? Next one. Oxygen atom in ether is. They are mentioned here. Oxygen atom in ether is. I already mentioned. When we discussed about the chemical properties of the ethers, I already mentioned. The oxygen in the ethers are relatively, you know, inert. They will not, if you do the reactions and they are very stable. They are very stable to the reactions, like if you add acid, base, or if you add any reducing agent, they are very stable. Why? Because this is oxygen in the ether is comparatively it is very inert. So if the ether to participate in the reactions, you have to maintain the drastic conditions I already mentioned. So that's why the oxygen in the ether is inert. This is a inert, not very active. Clear? So option 3 is the correct one. Comparatively inert. Option 3 is the correct one. Clear? Next one, sixth question. Which of the following is a simple ether? I already said the classification of ethers. We have two types of ethers. One is simple ether and another one is mixed ether. Simple ether means you already know what is the simple ether. Simple ether means the two alkyl groups attached to the oxygen must be same. If they are same, that we will call as a simple ether, or we can also call as a symmetrical ether. Clear? If alkyl, both the alkyl groups, if I say R and here R dash, and both should be equal, then that ether we will call as a simple ether. If both are not equal and R dash, that we will call as a mixed ether or unsymmetrical ether. See now questions what they have given, options what they have given. The first one, CH3 CO CH3, this is option 1, and option 2, C2H5 OCH3, this is the second one, and third one is C6H5 OCH3, and the last option, fourth one is C6H5 OC2H5. They are asking which one is the simplest ether or simple ether. Both the alkyl groups here same, so it is the simple ether. And here C2H5, here CH3, it is a mixed ether, and here also it is a mixed ether, and it is also mixed ether. So your option is, so correct one is option 1 is the correct one. Clear? Next one, question number 7. An example of a compound with functional group O. Functional group O. Functional group O means what? Those are ethers. Functional group O it is there means it is a ethers. So first one, acetic acid, methyl alcohol, diethyl ether, fourth one is acetone. What is your answer here? Option 3, that is a diethyl ether. Clear? Which of the following, eighth question, question number 8. Which of the following do not contain an acyl group? An acyl group. What is the acyl group here? RCO group we will call as a acyl group. Acyl group. This is. Or you can simply say CH3C double bond O group we will call as a acetyl group or acyl group. They are asking, and which of the following do not contain acyl group? First one is acetyl chloride. You can say first acid chloride. You know what is the acid chloride here? Acetic acid, they have given acid chloride. Acid chloride means what it is? RC double bond O, Cl. This is acid chloride. So this is containing acyl group or not? Yes. Next one is amide. Amide means what it is? RCO NH2 we will call as a amide. So that's why it is also containing which group here? Acyl group. And next one is ester. Ester means RC double bond O and OR. This we will call as a ester. So ester is also having which group? Acyl group. And last one is here ether. Ether means what it is? R, O and R. So ether is having any acyl group here. What is the acyl group here? RCO. This group we will call as a acyl group. Acid chloride has, and acetic amides has, and esters has. So that's why, and these are means you just remember this. Acyl group will have the acid derivatives, acids and acid derivatives. Clear? Acid derivatives means acid chloride, amides, and ester, and acid anhydride also. Clear? This is the question number 8. Your option should be option 4 is the correct one, because it is not having compound. Now ninth one. Ninth one, what they have given. Name the CH3 twice CH and O CH2 CH2 CH3. CH2 CH2 CH3. Now they are asking IUPAC name. You know what is the IUPAC name of the ethers? Ethers IUPAC name is alkoxyalkane. What it is here? Alkoxyalkane. Clear? So smaller group we will consider it as a always, you know, smaller group will be always alkoxy, and larger one we will consider it as a, you know, alkane. So what is the here? They have given here in a common name, not they have asking here IUPAC name, because according to the options you see isopropyl propyl ether, dipropyl ether, diisopropyl ether, isopropyl propyl ether. So IUPAC name means this is the name, alkoxyalkane, but they are asking which one? Common name. Common name means, you know, and here also propyl group is there, isopropyl, and here also what it is? Propyl. So propyl, here also propyl. So iso you have to consider which come first in the alphabetical order, that you have to see. So what it is here? Isopropyl, and here propyl ether, isopropyl propyl ether. That is the your option, that is option 1 is the correct one. Clear? That is the question number 9. Acetals are, clear? What are the acetals? Clear? Acetals, question number 10. Acetals are, this question we will discuss in the aldehydes, ketones and carboxylic acid, but we will discuss what are the acetals. Acetals are ketones, diethers and aldehydes, hydroxyaldehydes. Clear? Option actually here diethers. How we will prepare the acetals? Acetals means first what we will take? We will take the acetal aldehydes. Clear? Take the here aldehyde. Clear? And this is treated with the alcohol. Treated with the which one here? Alcohol. I will write here ROH. This is alcohol. Clear? Now what happened, you see? This is C double bond O. C double bond O means, you know, this is a partial negative and this is a partial positive. Oxygen, you know, it is a partial negative and hydrogen is a partial positive. And you know, negative positive, positive negative, there will be a bond, and O attack here, and it will be oxygen electron, bond electrons will move towards the oxygen. Oxygen gets the negative charge, it abstract the H plus. Clear? Then what the compound you will get? You see R, you will get here O and H. Clear? And here already H is there and OR is attacked here. So OR. This we will called as hemiacetal. What we will call this is hemiacetal. Hemiacetal. Clear? Next one. Again another one molecule of alcohol react with this compound. Again what happens here? Again another alcohol ROH. Clear? So now what happened here? There is no carbonyl group to attack here. So that's why. And O and here OH will be removed as a water. So O and OH will be removed as which one? Water. Then what we will get? R and here COR and here OR and H. This we will called as a acetal. We will call as a acetal. You see now here two other groups are there, RCOC, ROC. Two other groups are there, that we will called as a diethers. What we will call here? Diethers. Remember again the same reaction we will discuss in the carbonyl compound, that is aldehydes and ketones. If aldehydes involves, we will call, you see, first of all, if they ask in hemiacetal is a monoether, it contains only one ether group, and but acetal contains diether groups ROR, ROC and ROC. Diethers are there. So your option should be what it is here. Option 2 is the correct one. Next one, question number 11. Question number 11, you see. What is the question number 11? The ethers, in ethers, the COC bond angle is, that we have already discussed in the, you know, structure of ethers. There we have discussed it is a 110. Clear? Option 3 is the correct one. And next one. So 12th question. According to the Lewis concept of acid and bases, ether is clear. So now first one option they have given acidic, basic, neutral, and they have mentioned amphoteric. Clear? You know that ethers I already mentioned, reactions of ethers. When we discussed about the reactions of ethers, and you know it is ethers are having two lone pair of electrons, they can donate the pair of electrons to electron deficient compounds. You know, according to the Lewis acid base theory, the compound means, you know, Lewis acid means electron pair acceptor, and Lewis base is a electron pair donor. So that's why it donates the electron pair to electron deficient compounds. So that's why it act as a Lewis base. It is a which one here? Lewis base. It act as a what it is? Lewis base. Clear? So option here, and the 12th question option is 2. Option is what it is? 2. Clear? Next one. The compound which is not isomeric with diethyl ether is. The compound which is not isomeric with diethyl ether. What is the diethyl ether formula? C2H5. C2H5. This we will call as a ethyl and ethyl, diethyl, and oxygen is there, ether. And option 1 they have given here with the compound which is not a isomeric with diethyl ether. First one is N-propyl methyl ether. Propyl methyl ether, CH3CH2. This is a propyl, and here methyl. Propyl methyl ether. It is a isomer or not? Yes. Here 4 carbons are there, and here also how many carbons are there? 4 carbons. Hydrogen 10. Here also 5, 5, 10. So it is both are isomers only. Next one is butane 1-ol. You know butane 1-ol means, and you know what is the compound? CH3, CH2, 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 OH. You already studied in the first year. Alcohols and ethers are isomers, functional isomers. Clear? So here OH alcohol and here ether, same molecular formula. So alcohols and ethers are functional isomers. And next one, 2-methyl propane 2-ol. 2-methyl propane 2-ol. Propane means, you know, CH3, and here 2-methyl, and here CH2OH. 2-ol they have mentioned. 2-ol means here OH, and this is CH3. You know this is ether, and it is also having 4 carbon atoms and OH. Ethers, you know, alcohol and ethers are functional isomers. Here also 4 carbons, here also 4 carbons, and here also oxygens 10, hydrogens 10, and here also hydrogens 10. And fourth option they have given butanone. What is the butanone here? CH3 and CH2, butanone, and CH2, and here CO, and here CH3, butanone. Clear? So here you see carbons 4, but hydrogens how many are there here? 6, 6, and 8. So it is not an isomer of diethyl ether. So this is the, you know, the option here is fourth one is the, it is not a isomer of diethyl ether. Clear? Next one. 14th question, question number 14. The structure of diethyl ether is conformed by, it is not a actual structure, and how diethyl ether is prepared by should be there. You know that ethers are mainly prepared by which reaction? Williamson synthesis. By using which one? Williamson synthesis. That is actually wrong question. Structure of diethyl ether is conformed by they are asking. Conformed by means it is not exact the question here actually. So how to prepare? By seeing the options we can say how which method is the best method, means correct method to prepare the diethyl ether. You know coal based synthesis. Coal based synthesis, what we prepared here? In the coal based synthesis, salicylic acid is prepared from the phenol. And you know next one is Franklin synthesis, that we will, you know, it will go to the alkanes synthesis actually. Next one is wood synthesis. Wood also, you know, preparation for the alkanes. Williamson synthesis. Williamson synthesis, you know, it is used to synthesize the ethers. What are the reactants? Alkyl halides and you know alkoxides. Clear? That is. So next one is question number 15. Fourth question answer is 4, and the next one is 15th question. Fermentation is an, they have mentioned endothermic, exothermic, reversible reaction, and none of these. Clear? And you know fermentation is a exothermic reaction. During the process, heat energy is released. During the process fermentation, we have already discussed, and you know sucrose C12 H22 O11 plus H2O, and invertase we have used invertase. Then what we got here, C6 H12O6 and again C6 H12O6. One is glucose and another one is the fructose. One is glucose and another one is the fructose. So now in this one, next one, what happened here, C6H12O6 and here zymase enzyme, zymase. So what happened here, you got 2 moles of C2H5OH plus carbon dioxide, and plus here also what will happen here, heat is generated. So heat is generated means, you know, this reaction we will called as a exothermic reaction. What it is here, exothermic reaction. So that's why fermentation process is a exothermic reaction. And which gas is released during the, you know, fermentation process? Carbon dioxide gas. That is also one question is there. So that's why you see the question number 35. Question number 35, here only I will discuss, and this is question number 35, next question. Clear? See what is, which gas is eliminated in fermentation? Options they have given wrong. First one they have given here oxygen, second also they have given oxygen, actually it is not a oxygen, carbon dioxide, you correct it. And third one is nitrogen, and fourth one is hydrogen. What is the gas released during the fermentation process? That is a carbon dioxide. So that's why, and these are the means in the fermentation. So next question is, we have discussed up to the 15th. Question number 16. Question number we will get 16. See the question number 16. So what is there? Question number 16, and they have mentioned nitroglycerin. What it is here? Nitroglycerin. Nitroglycerin is nitroglycerin. And first of all, you must know what is the nitroglycerin. Clear? So whenever glycerol CH2OH, you know glycerol formula already, and here CH2OH and reacted with HNO3. What it is here? HNO3. HNO3 can I write and HNO3. Or you can write the structure here and HNO3OH and here NO2, and here also OH NO2. HNO3, this is how many moles I am taking here? 3 moles of HNO3 I am taking. Clear? So this is, and heat it in presence of acidic medium. Then what happened, you see, H and OH will be removed, and here also H and OH will be removed, and here also H and OH will be removed. Means 3 moles of water is removed here. Then what the compound you will get, you see, you will get the compound here is CH2O and here NO2, and here CHO and here CH2 and NO2. Trinitroglycerin. This is what we will call here trinitro. How many nitro groups are there here? 3. So trinitroglycerin or glycerol. Trinitroglycerol. This can also be called as a nitroglycerin. This is nitroglycerin. It is a ester. It is a what? It is ester. See now what it is there, CH2O and here N double bond O, and we can write here O minus. This is the structure actually. Clear? You know CH2 and O, C double bond O minus. If it is H is there, what we will call here? This is a R. Suppose anything is there, it is like a what it is? Ester. Ester group is present or not? So that's why this nitroglycerin is a one type of ester. ONO2, OCOO. Clear? So that is it is NO2 group is there, and here oxygen is there and NO2 is there. This we will called as a ester. So that is your option, an ester, an alcohol, a nitro compound, an acid. So your option is here an ester. Question number 17. Which of the following are known as mercaptans? Clear? So mercaptans are thioalcohols. Thioalcohols can also be called as mercaptans. So option 17th question, option 1 is the correct one. Clear? So mercaptans. Next one, 18th question. 18th question, you see what they have given, and just change this CH2 CH2, and they have given here B2H6 and B2H6. Next here hydrolysis, B2H6 hydrolysis. It should be in, actually it is a peroxide. In the presence of peroxide it should be. So basic hydrolysis it should be H2O2 and OH minus. They have given H2SO4. You just correct it. And H2O2 and OH. So they are asking product. They are asking here product. You know what is this one? We have already discussed hydroboration and oxidation, HBO method, hydroboration and oxidation. I already mentioned how to write the product directly in the hydroboration and oxidation. How to write the product here? You know that directly you have to add the water according to the anti-Markovnikov rule. That is the final product. What is the final product here? Add water H2O to alkene according to which one here? According to anti-Markovnikov rule if the alkene is a unsymmetrical. But here alkene is a which one? Symmetrical. If you break CH to this side and CH to this side, this is a symmetrical. So that's why you need not to follow. Directly add the water here. What is the compound here? CH2 double bond CH2. What is the final product in this one? We have to add the water according to the anti-Markovnikov rule. But here symmetrical. So one place you add the H and another carbon add the OH, and double bond is converted into single bond. Then what you will get? CH3 and CH2 OH. This is the product. What is the product here? Ethyl alcohol. So option 2 is the correct one. Option 2 is the correct one. Clear? So this is question number 18. Next one is question number 19. See the question number 19. Phenolphthalein is obtained by heating phthalic anhydride with a concentrate H2SO4. Benzyl alcohol, benzene and phenol. How we will prepare the phenolphthalein? Phenolphthalein, indicator it is. You might have studied in the practicals, first year practicals. Phenolphthalein we will use as an indicator, acid base titrations. Clear it is? So how to prepare that one? We will prepare that compound by phthalic anhydride and phenol. What is the phthalic anhydride? The phthalic anhydride means you have to take the phthalic acid, CH3COOH and COOH. This we will called as a phthalic acid. Phthalic acid. Anhydride means what? From the acids you have to remove the two acids, you have to remove the water molecule, and here remove the water molecule, one from H and another from OH, heat it, then you will get the phthalic anhydride. This is, and CO and here CO, here CO and here CO, one O is left here, that is. This we will called as a phthalic anhydride, or simply you can write here CO means C double bond O, and here there is a C double bond O. This we will called as a phthalic anhydride. Clear? So this is phthalic anhydride. This phthalic anhydride is reacted with the 2 moles of phenol. Reacted with how many moles of phenol? 2 moles of phenol. Means I will write here 2 moles of phenol. This is 1 mole, and another mole I will write here. This is the another mole. H and here H and here there is a OH. And now these two should be treated with the concentrate H2SO4. What is the concentrate H2SO4 role here? It act as a dehydrating agent. Concentrated H2SO4 is a dehydrating agent. So that's why remove the water molecule, 2 H's from the para position and 1 oxygen from C double bond O. Remove this. This is a water molecule. Remove the water molecule. Then what the product you are getting? You will get the product is, so here phthalic anhydride means this is the product you will get, and here C double bond O, and here C, and there will be a O, and here there is a one phenol group will be present here. This is OH, and another one is here. This is OH. This we will called as a phenolphthalein. Clear? So now phenolphthalein is produced by which one? Acetic anhydride reacted with 2 moles of the phenol. So that's why you will get here phenolphthalein. Phenolphthalein. See, one is phenol. Here only it is there. So how we will prepare means phthalic anhydride. From phthalic anhydride, how we will phenolphthalein will be prepared means one is you see here phenol. So their only option is there. Phenolphthalein, phenol is there. So that's why we should prepare the phenolphthalein from the phenol and phthalic anhydride. So phthalene. So that's why phenolphthalein. Clear? So this is how many moles sometimes they will ask. To prepare the phenolphthalein, phthalic anhydride should be treated with how many moles of the phenol? How many moles you have to take here? 2 moles of the phenol. So what the reagent we will use here? Concentrate H2SO4. What is the role of that one? Act as a dehydrating agent and remove here water molecule. This is phenolphthalein. Clear? Next one is maltose. Clear? This we will discuss. Carbohydrate chapter is there in the second PUC. There we will discuss. So just I will discuss here. Maltose, if you know, it contains 2 glucose units. Clear? If you take the maltose and do the hydrolysis, you will get the glucose, 2 moles of the glucose. Here what is the maltose formula? Same formula here, C12H22O11. You will get here maltose hydrolysis. You will get the C6H12O6 and here also C6H12O6. What is this one? Glucose. This is a glucose and this is also what it is? Glucose. This, what is the name of this compound? Maltose. You see now sucrose if you take, you already know what is the sucrose formula. Same formula only, C12H22O11, and if you treat this one hydrolysis, and here you know sucrose, here sucrose. Clear? And sucrose means you will get same compound only, C6H12O6 and C6H12O6, but one is a glucose and another one is a fructose. What is the difference here? Here formulas are same but functional groups are different. In this glucose the functional group is aldehyde, in the fructose the functional group is here ketone. So that we will study in the second PUC only, don't bother about this. And next one is 21st question. Your answer is what it is here now, and this option C is the correct answer for you. Absolute alcohol can be obtained from rectified spirit. Clear? So absolute alcohol can be obtained by rectified spirit. You know what is the rectified spirit? Rectified spirit means 95% of ethanol and plus 4 or 5% of H2O, and this is we will called as a rectified spirit. This is a rectified spirit. From this you have to get the 100% of alcohol. Alcohol means what it is? Ethanol, C2H5OH, means this what we will call absolute alcohol. So they are asking how to convert, how to prepare the absolute alcohol from the rectified spirit. Rectified spirit containing how much water here? 5%. If you remove the 5% of the water, then total there will be a alcohol, 100% alcohol. Can we do this one distillation? We cannot do. Why? Because it is a azeotropic mixture. Azeotropic mixture. You know, in the solution you might have studied about the azeotropic mixture. Clear? You know that 95% of ethanol plus 5% of water forms azeotropic mixture. Azeotropic mixture means, you know, and they boils at constant temperature. They boils at which temperature? Constant temperature. Suppose, and you know ethanol, I have ethanol, and what is there here? Water. What is the boiling point of water? You know, 100 degree. What is the ethanol boiling point? It is almost 79, almost 80 degree. It will be 79. Clear? But if it is a 95% alcohol and 4% ethanol, both the mixture will have here almost 78 degree temperature. Means what it is? If you maintain the 100 degree centigrade, water will not evaporate, and both mixture will boil at same temperature. That we will call as the azeotropic mixtures. Clear? How to separate the azeotropic mixture? We cannot separate the azeotropic mixture. Why? Because they distilled at constant temperature. Distillation, fractional distillation, we should not be used. So which one we will use here is azeotropic distillation. What we will call that concept is azeotropic distillation. Azeotropic distillation. Clear? This should be used. How we will do means, I will not discuss detail here. So what we will do, to this mixture we will add, to this mixture what we will add here? Benzene. What we add here? Benzene. By adding that benzene, the benzene boiling point should be less than the azeotropic mixture. Azeotropic mixture. And then slowly we can remove the water molecule here, and that is we will call as a azeotropic distillation. If you discuss about the azeotropic distillation, it is so much will be there, that is not required for you also. Simply remember, azeotropic mixtures are separated by azeotropic distillation. For azeotropic distillation, you know, third solvent is required. What that solvent we will use here? Benzene. The benzene boiling point should be less than the azeotropic, means the what the third solvent we are using, that boiling point should be less than the azeotropic boiling point, then only the azeotropic distillation is possible. Clear? So that is your answer should be here, by distillation with appropriate amount of benzene. By distillation with appropriate amount of this benzene. That is option 3 is the correct one. Next question. 22nd. Grignard reagent react with compounds containing which of the following group? You know what is the Grignard reagent? RMgX is the Grignard reagent. Clear? So it react which of the following compound? First one they have given C double bond O. You know that Grignard reagent, and you know this is a positive charge, and Grignard reagent on the R, on the carbon, if the bond breaks here, if the bond breaks, you know metal always positive charge, and in the Grignard reagent and carbon gets the negative charge. Negative charge means it acts as a nucleophile. Nucleophile means if any there is a electrophilic center. Electrophilic center means any positive charge in the molecule, then they attack. Clear? See now. And carbon and oxygen, you know carbon is more electronegative than the oxygen. Oxygen gain electrons and carbon lose electrons, then you will get the carbon is a partial positive charge. You know oxygen is a negative charge. So that's why here R minus attack here. Then what the compound you will get? R, and you know, and I will write in this way. There will be a R and O minus, and here MgX. It will react with the C double bond O and also with the C triple bond N, because you know here R minus and Mg plus and X, you know this is more electronegative. Nitrogen is more electronegative than the carbon, so that's why, and carbon gets which charge? Positive, and nitrogen gets the negative. Here which charge? Negative, so that's why attack here, this bond electron will move. Clear? It is also reacted with the cyanide. It requires electrophilic center. These molecules are having electrophilic center, positive center, so that's why it will attack. And next one is C double bond S here also. And oxygen, you know carbon and sulfur. Sulfur is more electronegative. It will acquire the partial negative charge. carbon acquires the partial positive charge, so that's why here R minus and Mg plus X nucleophile attack here. So this Grignard reagent will react with the all of these compounds. Your option is option 4. Option 4 is the correct one. Clear? Next one. Next one, they have given question number 23. Question number 23, they have given Acyl plus NaOH is giving rise to glycerol plus soap. What is this reaction? They have mentioned sulfonification, esterification, hydrogenation, none of the above. So this is fats, Acyl. So here this reaction we will called as sulfonification. Clear? It will be there in the one of the very important question in your PU examination. That structure, everything will be there in another chapter. There we will discuss. Just here you remember what is the name of this reaction. So their reactions also there, and hydrolysis, and very important question for your PU examination, and last chapter it is there. There we will discuss what is this sulfonification detail. Clear? Next one. See the question number 24. Question number 24. Acetone on treated with methyl magnesium iodide and further hydrolysis. Acetone. What is the formula of acetone? CH3, C double bond O, CH3. This is the acetone. Is treated with the methyl magnesium iodide followed by hydrolysis. They are asking what are the products. I already said whenever formaldehyde reacted with the Grignard reagent followed by hydrolysis, you will get the primary alcohol. Very important this is, you have to remember. So you know that whenever formaldehyde, what is the formaldehyde here? CHO reacted with the RMGX followed by hydrolysis. Again I am repeating. So which alcohol you will get? Primary alcohol. Very important. Other than any aldehyde, other than formaldehyde, so any aldehyde you take RCHO and plus RMGX and followed by hydrolysis, you will get the secondary alcohol. Clear? And next one, ketones are there. RCO are ketones, and hydrolysis, Grignard reagent and hydrolysis, you will get the tertiary alcohol. And also all acid derivatives, acid chloride, acid means ester, and acid anhydride RCO and OC double bond O and R, all these acid derivatives are treated with the RMGX and followed by hydrolysis. You will get the alcohol. It is excess amount you have to take. This we have already discussed. Clear? Now in this one they have given ketones and reacted with the Grignard reagent. What the compound, what the alcohol you should get? Tertiary alcohol. You should get the which alcohol here? Tertiary alcohol. Clear? So tertiary alcohol means how the reaction you have to write? Simple. Take this one, CH3, C double bond O and CH3, and here what you will get? CH3 MgI. CH3 MgI. Clear? Simple. You know that. And this is a negative charge, and this is a negative charge, and this is a positive charge. Always you remember here, the methyl group in the Grignard reagent should be added to the carbonyl carbon and convert the double bond oxygen, double bond O into OH. That is the final product. See now, what is this one? CH3, and here CH3, and one of the CH3 should come from which one? Grignard reagent. And when it go, and O minus MgX, further hydrolysis, and you will get the OH. That is how to write the product directly. Clear? Simple. Suppose another compound I will give. Suppose CH3, C double bond O and H is treated with the C2H5MgBr. C2H5MgBr and followed by hydrolysis. Write the direct product. Direct product means what it is? 2 carbon, CH3 is there and H is there. And this alkyl group should be added to carbon and convert the double bond O into OH. That is the final product. And what it is? CH3 and C, OH and H. What is the group is there here? Grignard reagent, that you write C2H5. Clear? So your answer is, this is, what is the answer you say? Isopropyl alcohol, primary alcohol, acetic acid, 2-methyl 2-propanol. This is 2-methyl 2-propanol. Option 4 is the correct one. Next one, see the question number 25. In the following reaction A is, they have given here C2H5 MgBr, means ethyl magnesium bromide, Grignard reagent, and they have given here epoxide CH2 and O. Clear? Then followed by hydrolysis, and they are asking what is A. Here final product you are asking. Same example, means I have discussed in the PU part only, and Grignard reagent reacted with in the preparation of alcohols. I mentioned this one. So Grignard reagent reacted with the epoxide, ethylene oxide can also be called epoxide, and what will happen? Followed by which one here? Hydrolysis. So you know that what happened here, C2H5 means when it breaks, this is what we can write, CH3, CH2. If the bond breaks, carbon gets the which charge? Partial negative charge. Negative charge, it is a ring. Ring is a 3-membered ring. It having so much angle strain. So that's why it is a unstable. So it try to opening the ring if any nucleophile is present here. If any nucleophile, and if the epoxide see any nucleophile, so what it will do? It will try to react with that nucleophile to get rid of from the angle strain. And ring opens. When ring opens, strain will decreases. Clear? So that's why. And a nucleophile is there here. Both are, it may attack on at any position, but which one it follows? SN2 mechanism. If any substituents are there, and where less substituents are there, where the steric hindrance is less, there nucleophile attack takes place. So now what happened here? When it attack here, and this already 4 bonds are having this carbon, now it is making another bond, means 5 bonds. So that's why this bond will break. It move towards this bond pair electrons towards oxygen. Then what the compound you will get? You see CH3 and CH2. CH2 is make a bond with which one? This is CH2, and here another CH2 is there, and it is O minus. O minus means here which one is there? Mg plus. Minus and plus, there will be a bond. So MgBr, and followed by which what they have given? Hydrolysis. Hydrolysis means and break the bond here H and OH. Because if the bond breaks here, H means water, means how we will write? H plus and OH minus. Magnesium positive, oxygen negative. So that's why negative and positive bond and positive and negative bond. So that's why you will finally get CH3, CH2, 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 OH. Clear? So how many carbon atoms are there? Suppose sometimes they will give Grignard reagent, and here final product, in the final product more than 2 carbons are there compared to the Grignard reagent. Grignard reagent having how many carbons? 2 carbons. But here how many carbons? 2 carbons extra. Means definitely the Grignard reagent is reacted with the epoxide. Clear? That is also. So that is your answer should be option 2. C2H5. That is option 2 is the correct one. Clear? Next one. See the question number 26. What is the question? Sodium benzene sulfonate. What is the sodium benzene sulfonate? This is sodium benzene sulfonate. Benzene sulfonic acid. Instead of H, Na is there. Sodium benzene sulfonate reacted with NaOH. Reacted with NaOH, then followed by hydrolysis. Then they are asking it gives what? You see, I have already discussed this one in the preparation of phenol. Preparation of phenol from the benzene sulfonic acid. Have you remembered or not? Once you check it. So what we have discussed there? We have taken benzene, and benzene is treated with the concentrated sulfuric acid, or oleum I mentioned, H2S2O7. Sulfonation takes place. What the sulfonation here? SO3H, this is the sulfonation, then treated this one with the NaOH. NaOH means it is a acid and it is a base. You know water will be acid and base react and water will be removed. Then what the compound you will get? You will get the compound is SO3Na, sodium benzene sulfonate. This is only. Now it is treated with the 2 moles of NaOH. Have you remembered or not? So what you will get here? Na2SO3 will be removed. Here 2 Na and here SO3. Na2SO3. Na2SO3. Clear? And now you know that here 2 OH are there here. OH and OH, 2 OHs are there here, and it will be removed as a water. Minus water. And here what is left here? 1 oxygen is left, and here which one is there? 1 sodium. So that's why you will get here sodium phenoxide, and followed by which one here? Hydrolysis, and here H and OH. Then what the compound you will get? You will get the compound is phenol. So that is same question indirectly they have asked here. So if you are very perfect in the PU, and that questions only it will come in the most of the time in the competitive examination. This is question number 26. Next one is question number 27. What is your option now? Option 1 is the correct one, phenol. You are preparing here which one? Finally phenol. So question number 27. Phenol is obtained by heating aqueous solution of. Phenol is obtained. Phenol is obtained by heating aqueous solution of. You have to heat this one. With which of the compound here? Aniline, benzene diazonium chloride, benzoic acid, none of the above. You know this is another one preparation of phenol by the benzene diazonium chloride. In the NCERT textbook we have discussed already. Preparation of phenol. Clear? First one is a Dow's process from chlorobenzene, and second one is from benzene sulfonic acid, that is this one, and the third one is from the benzene diazonium chloride. This is we will call as benzene diazonium chloride, treated with the water and warm water. There we mention means heating, warm water. N2 will be released here, N2 gas, and here Cl is there, 1H will be removed as a HCl, OH is left here, OH will be added here. What you are getting here? Phenol. So your option should be, this is benzene diazonium chloride. Benzene diazonium chloride. This is benzene diazonium chloride. Your option is option 2. Clear? Next one is question number 28. See the question number 28. Grignard reagent, that is methyl magnesium, reacted with methyl magnesium iodide react with formaldehyde. What is the formaldehyde formula? HCHO. And what is the final product? I already said formaldehyde and Grignard reagent. Which alcohol? Primary alcohol. You can see by options. Without doing this you can put the tick. First one aldehyde, not the option. Second one propyl alcohol, CH3 CH2 CH2OH. Option B is CH3 CH2 CH2OH. Propyl alcohol. It is a which alcohol? Primary alcohol. Next one is ketone, acetone they have given not. Next one is ester. Which one is the product here? Alcohols are the product, so that's why option 2 is the correct. And directly how to write the direct product I already mentioned. How to write here? What is the alkyl group is there? Added 2 carbon here and make the double bond O into OH. So H, and here make the double bond O into OH, and here H, and add here C2H5. This is C2H5. How can I write this product? CH3 CH2 CH2OH. This is only. So our option 2 is the correct one. Clear? Next one, 29th question. Question number 29. So which one is not synthesized by Grignard reagent? Which one is not synthesized by Grignard reagent? Clear? See here what is not synthesized by Grignard reagent, and you know that options they have given here. One is primary alcohol, secondary alcohol, ketones and ester. Primary alcohol we can prepare or not Grignard reagent. Just now only mention RMGX. If you take the formaldehyde plus RMgX followed by hydrolysis, what you will get? Primary alcohol. Clear? And other than primary alcohol, other than formaldehyde, take any aldehyde, C double bond O and H, RMgX and H2O, which alcohol you will get? Secondary alcohol. Clear? Secondary ketones can be prepared or not? Yes, we can prepare the ketones also. How? Take the acid derivatives, acid chloride or acid, ester, acid anhydride. If I take here 1 mole of Grignard reagent, 1 mole of which one here? Grignard reagent. Then what happened here? You see, and for the halides, how to write means, take the here RU add and Cl first will be removed. Clear? How to write the first product here? R, C double bond O and remove the chlorine. Then this what you are getting? Ketone. But if you take excess amount RMgX, then what will happen? You see, and here 2 R's are there, 1 R will come from where? From the Grignard reagent and make the double bond into triple bond, double bond into OH, double bond O into OH. Which alcohol you are getting? Tertiary alcohol. I mentioned or not? Whenever acid derivatives react with the Grignard reagent, which alcohol you will get? Tertiary alcohol. When? If you take the excess amount of the Grignard reagent. If 1 mole if you take, this is also I discussed in the PUC class. If 1 mole you take, acid derivatives are converted into first which one? Ketones. So that's why ketones can also be prepared, but esters cannot be prepared. So that's why your option is here, option 4.